everybody. So we're going to do surface area now. But first, there's my dog Grace. All right, back to the math. All right, so the basic idea of what we're doing is we're going to get a thing called the frustum, which is actually part of a cone. And we're going to take that frustum and we're going to sweep it around an axis like we've been doing. And the net effect for our formula is going to be 2 pi r, there's that circumference thing again, times the length of the piece, which is the frustum. But it's not really that simple how it got developed. So I'm going to show you the idea. I'm going to show you the actual development of the formula, but this is the part that you really need. Okay, so and if you think about it, you're just taking the wedge, like you're taking this little wedge right there and you're just sweeping it around. So you're generating just the outside of the graph and how much surface area there is. Okay. What we're going to start with is we're going to start with a cone. We're going to have a cone where we're going to pop the top off. So the cone's just going to be this part of the cone, or the piece of the cone we're working with is just this piece. And this part right there is referred to as the frustum. And what we're going to have is we're going to have a radius of the base, and we're going to have a radius of the small part. We're going to have a slant height, and we're going to have a, I will describe it as part of a slant height, but this is our frustum piece. And then the surface area, the lateral surface area of a cone is pi times the radius times the slant height. Well, let me pick up here again, and we're going to use similar triangles. And we're going to have that the radius of the small cone divided by the radius of the big cone is equal to the slant height of the big cone minus the L. So that is our frustum. So we subtract these two, and we're actually going to get the slant height of the smaller cone. And then we're going to have the slant height of the big cone. So small to big, radius to radius, slant height to slant height. All right, now I'm going to turn the page. We're going to take that proportion, we're going to cross multiply, and we're going to distribute. And we are going to get the s's together. So I'm going to bring this across. And then what I will end up doing is I'm going to take this negative, I'm going to pass it through. So this will become positive, positive, and negative. Factor out an s. And so now I can get my slant height being equal to the radius of the big cone times the frustum divided by the radius of the big cone minus the radius of the small cone. Okay. So we're going to talk about S of F as the lateral surface area of the large cone, okay, minus the lateral surface area of the small cone. That's our S of F. So it's the surface area built off of our frustum. So we're going to take pi times the radius of the big cone times the surface, or times the slant height, minus pi times the radius of the small cone times that thing's slant height. Where is this coming from? Well, I'm going to go back for a second and remember that the surface area of a cone is this formula. I'm just trying to put variables in there so we can kind of see what's going on. Now, S in both cases, this S is this S. This is our slant height. Okay, so we're going to take pi, radius of the big cone, times the slant height, times S, and then we're going to have pi times the radius of the small cone, times the slant height minus L, the little cones, or the frustum piece, okay? So you see this part is that part. That's our S. If I travel back, where did I stop? So this S is that S and that S. Just making sure you're seeing that. All right, so now we're going to go RB times RB. You can get some good curly fries there. Haha. So we have RB squared. We're going to have RB and RS, those two getting multiplied. And then we're going to have pi RS with the L going on. We're going to go through the process of getting a common denominator. So we're going to multiply this piece by RB minus RS, RB minus RS. So that's a funny way of looking at a 1, but it is a 1. And we're getting the RB minus RS from here and from here. All right. I'm going to pause for just a second. I'm going to let you guys catch up in terms of writing. At the same time, I've got to double check my notes. Okay. So what I'm going to do from here to here, from this step to this step, is we're going to distribute this factor times RB, and then we're going to take this factor times RS, and remembering that that's a common denominator, so it's going to belong to both components. Both components when we split it out. Okay, you're going to notice that this piece is negative and this piece is positive, and they are the same term, just one's positive and one's negative. And so they're going to go away, and we're going to be left with pi RB squared L minus pi RS squared L. And what we'll do is we'll factor out of these two pieces an R and an L. I'm sorry, a pi and an L. We pull those out. We're still over RB minus RS. This is a difference of squares, so we can factor it. And you'll notice that RB minus RS cancels. And we're left with pi times RB minus RS times L. Now, RB is the radius of the base, and RS is the radius of the smaller of the two cones. Let me go back for a second, just point that out. So this piece is the RB, this piece is the RS, and if we're looking up here, here's our RB and here's our RS. I'll travel back. I'm about at my 10-minute video limit, so I got to stop here, and I'm going to make a second video.